everyone, welcome to my YouTube channel. Today I'm gonna show you how to do soccer league statistics among these countries you are seeing now. So goal of this video is to create a box plot and compare a number of shots on target, corner kicks, fouls, yellow cards, and red cards among the countries you saw on the previous slide. Procedure: first of all, I'm going to import the data. From the data, find the variables, then compare variables, and I'm going to find which countries are different from each other, then create Excel files. So I'm going to show you how to do this by using MATLAB, but I'm going to create an Excel file, export it, and I'm going to do kind of same statistical analysis in spreadsheet and R. So let's go to MATLAB. Okay, MATLAB, first of all, I'm going to import the data, but before importing data actually, I have to collect the data. So I go to a website called Football Data, and this website gives you a lot of data such as about England, Scotland, Germany, Italy, like Serie A, Bundesliga, Liga Española, blah blah blah. But in this video, I'm gonna use data in England, Scotland, Germany, Italy, Spain, France. You just click one of the countries and click the first file, or 2019 and 2020. You click it, download it, and import it into MATLAB. I already have imported data here: England, France, Germany, Italy. So I'm just gonna save all data into variables. Right here, let's take a look at what's inside. So 380 times 106 table. So 380 is the number of rows. Each row represents each game, and 106 is a number of columns. Each column represents each variable, such as home team, away team, FTL, final time result, blah blah blah. But in this video, I'm gonna use home shots, away shots, home shots on target, away shots on target, home fouls, away fouls, home corner kicks, away corner kicks, home yellow cards, away yellow cards, home red cards, and away red cards. Then let's find the variables. So first of all, I'm gonna make a struct because each table has different dimensions, so I cannot use table to collect all data into one variable. So I use, if I run this, you will see what I mean. So if I open the variable called Ligue, there are all tables but different dimensions. Then I define name in alphabetic order from England to Spain. Then this for loop extracts the data about the variables such as home shots, away shots, shots on target for away and home. So what this function gets filled at is to access to struct, because struct is very easy to store data, especially with different dimensions. But it's a little bit difficult to extract the data. But if you use this function, you just need to put struct and name of the field, which is I defined here. For example, first loop is England, so get field function extract data about England and variable home shots. And I'm gonna add home shot with away shot because I only need a total number of shots. Then this square bracket, make sure I'm gonna create long format data. I'm gonna explain why I need long format instead of wide format later on, but pretty much I'm gonna add number of shots for England. Then right after, I'm gonna add a number of shots for France and Germany, Italy, Scotland, Spain. So dimension is gonna be 1 times whatever number for each country. Then I'm gonna run this and you will see what I mean. So for example, fouls, the dimension is 1904 times 1 because the dimension for England is 380. So first 380 is for England, and the second 297 is for France, and the next 306 for Germany. So this is all data in long format. Then I found all variables, so we are ready to conduct an over and a post hoc test. But actually before that, I have to create the name. So I have all variables, but I need a corresponding data or name. So like I said, England has 380 games, so I have to create sequence of England 380 times. So this for loop creates England 380 times. So England, 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 England. Then this for loop creates France, 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 and this for loop creates Germany, 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 then Italy, Scotland, Spain. Then I'm gonna put all together and save it into variable called group. So if I run this, I get group here. So dimension is the same, 1 times 1904, and you get like this. I'm not gonna scroll all the way, but basically this is long format. Then we are ready to calculate or conduct an over. An over 1 is a function, and input is just shots like I just created in long format, and name, like corresponding name, which I created here, a group. Output is p-value and statistics. There is another output in the middle, but in this video I'm not gonna use it. So let's run this. So if I run this, the function creates box plot automatically, also an over table. So f statistics is less than 0.05. So obviously at least one pair of countries is different, statistically different, but we don't know which pair. Maybe England and Germany, or maybe Italy and Spain, or Scotland and France, we don't know. So that's why we have to do post hoc test, which is here. You can use multiple compare function. You just need to input stats from an over. Then if I run this, you get figure first. So reference is England, and I don't think France is statistically different compared to England, but statistically different with Germany, Italy, Scotland, Spain. Let's check it out. So the name of the output is C-shot. Look at this. So first and the second column represents country actually. It's like a dummy code. 1 represents England, 2 is France, 3 is Germany, 4 is Italy, 5 is Scotland, 6 is Spain. So as I said, England and France is not statistically different because column 6 is p-value. But other countries like Germany, Italy, Scotland, Spain is statistically different. And column 4 is difference, and column 3 is 95% confidence interval and lower bound, and 5 is upper bound. Then let's take a look at England and Germany. It gives you negative value, which means that Germany has higher value than England. How about England and Italy? It gives positive value, which means England has higher value than Italy. Except for this pair and this pair, all pairs are significantly different. That's how you interpret this data. Then you're gonna do for shot on target, fouls, corner kicks, yellow cards, red cards, and so on. After that, create an Excel file. So I'm gonna do statistical analysis in spreadsheet and R. So I need this data. So again, I'm gonna create wide format this time, not long format. So I'm just gonna get rid of square bracket I had before and use same function get field. Then this for loop accumulate variables I want, like shots home, shots away, shots on target, home and away. Then I'm gonna define variable names, which is shots on target, corner kicks, fouls, yellow cards, red cards, and I'm gonna create table names. This just country name, and this for loop create a table for each country, not for each variable, because if you remember, in each country has different dimension. So I'm just gonna create a table for each country, then just write the table function to save the data into MATLAB. So I already did it before, so I already have Excel data here, like England, France, Germany, Italy. So let's export Excel files and do some statistical analysis in spreadsheet and let's go to spreadsheet. Okay, spreadsheet. So this is a Excel file just created in MATLAB. Then I just open it in the spreadsheet. Then the data looks like this. Shots on target, corner kicks, fouls, yellow cards, and red cards, and there are all variables. So 2 to 381 because 380 games and 380 data points. So what I'm gonna do is I'm gonna do copy and paste for only shot variable and put it into another spreadsheet and create something like this. So this is only for shots. So shots for England, shots for France, shots for Germany, shots for Italy, Scotland, Spain, blah blah blah. And if you go to the next page, you will see shot on target for England, France, Germany, Italy, Scotland, Spain. And pretty much what I did is copy and paste and create another table. Don't worry, I'm gonna give you all data so you can do your own. Then I'm gonna find maximum, lower quarter, upper quarter, and minimum. So what I just did is just use function called max, function called quartile, and 1 because it's lower quarter, and the same function but 3 because it's upper quarter, and minimum for just function called min. I need this data because we used to have add-ons to create box plots very easily and do some statistical analysis such as ANOVA, but I don't know, Google has just removed those add-ons and we are no longer able to use the add-ons. So pretty much what I can do here is to plot box plot. So I'm just gonna select all data, click insert, go to chart and select the box plot. Name is a little bit different, it's called candlestick chart, but pretty much same as box plot. So this is all you can do in spreadsheet, and I felt so bad. I researched actually and tried to find out how to do ANOVA in spreadsheet, but only you can do is to calculate or conduct ANOVA manually. And there is no point to calculate ANOVA. I mean, you can try, but there are so many other ways, like you can use R, Python. If you have access to MATLAB, you can use MATLAB, and calculating or conducting ANOVA manually takes long time. So I'm gonna show you how to conduct ANOVA in R. I mean, R is free software. If you have computer, you can just install R and R Studio. Then you can just import data. I'm gonna put all data on my blog so you can just download it and you can import it in R Studio and you can do statistical analysis. So let's go to R. Okay, R Studio. So let's import the data first. So to import the data, you just click import data and file format is Excel and go to browse. If you import, you will see this spreadsheet, and I mean, this is a spreadsheet I just created, and this is based on variable. So obviously this is default, which means shots. So shots for England, shots for France, shots for Germany, shots for Italy. If you want to find the next sheet, you can just click shots on target and you will see all values. So I'm just gonna demonstrate how to import the data and how to analyze or conduct an over and a post-hoc test on shots. So let's import this data. So this is imported data. I only need these variables or these countries: England, France, Germany, Italy, Scotland, Spain. I don't need a maximum or like a lower quarter, upper quarter, max or minimum. Let's select all rows and columns from 1 to 6. So if you take a look at the stats I just created, you only have the data for England, France, Germany, Italy, Scotland, Spain. Then let's do box plot. So this is box plot. If I zoom in, you will see England, France, Germany, Italy, Scotland, Spain, R or MATLAB. It's very easy to create a box plot. You saw it on the spreadsheet. You have to define maximum, minimum, upper quarter, lower quarter, but if you just use programming language, you just need to type box plot and stats basically. Then let's do an over. I have to import or use a library to activate add-on called Teeter. Then Teeter has function called gather. So this line actually creates long format. If you remember, I created long format by using for loop, but R is very good programming language and so many varieties of add-ons. And if you use just Teeter and use gather, you just need one line to create long format. So basically input is stats I just created right here, and you need name of the column, which is country, because I need England, France, Germany, Italy, Scotland, Spain. If you remember, I used the for loop to create like sequence of England, and France, and I just put it together. But I just need to create column name and another column name, which is shots, or it could be whatever. It could be whatever for here too. And I need current column name, which are England to Spain basically. Then factor key equal true. Then if I run this, you get long format data like this. So shots and country and England. I'm not gonna scroll down all the way, but basically this is long format I created in MATLAB. Then I can conduct an over. Function is called A or B. What I have to do is just put column, shots, and country. So grouping variable, which is country, and just variable shots. And data equal data dot long, because this variables inside of this data. You can just use data long $sign shots data dot long $sign country, and you can remove this data equal, but this is much easier and a shorter line. So if I run this, and the summary function gives you the summary table of an over. So let's take a look at it. So F value is obviously less than 0.05, so statistically different, which means that at least one pair of countries is statistically different. Then we don't know which pair. I'm gonna do Turkey HSD, which is post hoc test. There are many ways to do post hoc test, but Turkey HSD is R-based, so you don't have to install new package. So you just type and put in variable, which I created right here. Then you just need to run this and create all pair. And the difference, lower boundary of 95% confidence interval, upper boundary, and this is p-value. So as you saw it on MATLAB, the pair France, England is not statistically different. And one more here, Scotland, Italy is not statistically different. And the second one, Germany, England, it gives you positive value, but if you remember in MATLAB, it gave negative value. It's because the order is changed. So it was England, Germany, but in this time, Germany, England. So positive value in this table means Germany has more value or higher value than England. And the same for Italy, England. It gives negative value, which means England has higher value than Italy. So that's it. Thank you for watching my video, and see you soon.